Um,
Yeah, good
yeah.
morning, everyone. Welcome to this guest lecture. Today we have the honor to invite Valentine Watt from ESCOL. Um, so he will talk about his his experience and encourage and inspires. Over to you, Valentine.
Okay. Thanks. Thanks everyone for joining in. So I'll start by obviously on the screen you can see we're going to go through DevOps OWASP Security, which is a newish one that is very heavily pushed right now, and any emerging information technology. But I go into details about myself first. So my name is Valentine Watts. I'm the founder of a company called Temsconsu, which started off as a consultancy firm and has done work for PwC, IAG Insurance, Hong Kong Bank, and Coates Hire, quite a few, federal government, and then we evolved to becoming a software company based on some of the demands we're having, and we expanded and grew the team. We now have a global team that cuts across Vietnam, Australia, obviously, Germany, and the States as well. So these are the Temscorp. Temsconsu obviously was the parent company, and then from there it made Temscorp. Temscorp is actually a DevOps company, or has developed a DevOps product called Omnium Light. We'll go into a little bit detail about that one as well. Xlight is a cybersecurity product which we've developed that adopts an approach of protecting your data 100% at the data layer. So very software driven and falls in line with the OWASP security model. And those are some of the sites there. So today we will dive into discussing cloud computing. Obviously, to do justice to all the topics up there, we need to go into cloud computing, software stacks, virtualization, containerization, OWASP itself, and emerging information technology trends. And we'll go through some of that. Now, I'll go through a lot of some material, I think about 15 slides, but I'm going to leave enough time to make sure that you can ask as many questions as you want, because I think me just sitting here and telling you all the stuff, I want to give you room, at least 15, 20 minutes, hopefully, for you to ask as many questions, because I think that would actually trigger the information you're looking for and trigger a better exchange of information. Now, the content and the structure. So the lecture, the intended outcomes and the structure. So I will start with an introduction to my career. And the reason I do that is because obviously with, I don't know, 10 years experience now of mentoring both QUT and at Griffith University and one in Victoria and in the States as well, what I've come to find is that a lot of people who are studying information technology, cybersecurity, software engineering, computer science, a good number go into these areas and not, in my view, have enough information to play to their passion and to their strengths, because it's a wide area. So I go into my career to give you an idea, hopefully motivate and guide you into the way you actually focus on an area within the field as well, which is the reason why I go into it as well. So how I started my career, a prelude to career path discussion. What is DevOps? The history, imagine how did it come about, why it emerged, the DevOps tool set. Cloud providers, obviously, AWS, Microsoft, the Google one, GCP, Lambda, some of the products there, the Lambda serverless tools, software stacks, and then we go slightly deep into that, and obviously take any questions as need be, and go into examples, commercial practice. I'm going to use Australia Public Service because that's one of the largest implementations I've seen recently on how all this come together and how it adds value. And obviously you use MyGov and you use similar tools as well. Some of these underpin, you're able to use some of those government portals as well. So obviously mentioned OWASP, software application security, which is now becoming a very big thing now, that if we are building applications and software, we need to make sure that we are thinking of security all through developing, even from architecting the solution, all through to delivering it, to testing it, to implementing it, all through going through that. Security must now be paramount in everything that we deliver, obviously the current climate. So building futures, building with the awareness that somebody could break into that system, or many people will attempt to break into that system to steal data, since data is now being commercialized, or stealing data is now being commercialized by cyber criminals. Becoming a DevOps, DevSecOps engineer. I've added this in the new slide. I've added this to give some understanding as well. If DevOps is the area you want to go into, these are some of the learning, some of the areas of learning that might be necessary for you to be able to be successful in that area. Obviously, emerging information technology trends that we will go through as well. So that's pretty much our content. And then obviously we'll go to any questions and related discussions as well. So this lecture will focus more on business use cases. Success or failure stories provide some more understanding of these concepts in addition to what you already taught or what can be gleaned from the internet or your textbook. I'm simply trying to give you a structure, understanding of how some of these concepts, how they've worked and how they've not worked, and hopefully provide some guidance on where we're heading with all this as of today. So my background in a little detail, I have a master's degree in information system technology from City University in London. I've also have a mini executive, did some mini executive studying in Harvard. And I'm an elected member of the British Computer Society, and a chartered information technology practitioner, member of the Forbes Technology Council. I've been responsible for delivering, both from consulting and through delivering through this set of companies mentioned here, over $400 million worth of value in the last 15 years to our clients. So that would be total value for all the projects that we've worked on to deliver. I operated at senior management level in several multinational companies, to include Citigroup. I was an RVP years ago, where you got as a resident vice president, Citigroup globally, and I was responsible for a data warehouse, the FX money market data warehouse that collected data from over 300 countries. I ran that with a team, a global team as well. I worked for Centrica, consulting for Centrica, the UK Lottery, Lloyds Bank, when the GFC hit, 2007 or 8, I remember now, when all the banks started buying up each other in London. Lloyds Bank ended up with 3 banks. I was one of the technical program managers involved in trying to get all the systems to work together seamlessly as well. It was quite a very large project that encompassed and covered over 1,000 people working on that project. I did insurance over here, PwC, Coates Hire, Gold Coast City Council, Sunbank, Australia Public Service as well, as I mentioned. Particularly, I think it was a Centrelink project. I worked directly and through third parties with Amazon, Google, and IBM. We've done all kinds of work. Well, with Temsconsu, we did a partnership with Temsconsu with Amazon and IBM, and with Xlight as well. We've done one with Google as well. I get invited to some of the events in Las Vegas. There's 60,000 people in one place. It's unbelievable, a number of people that attend those events. Right. I initiated and led the development and product launch of 3 innovative and disruptive products. Omnium Lite, a DevOps tool, which please feel free to have a look. It's focused on test environment management, and I'm going to go into more detail unless someone asks me more questions, but its focus is on automating the way test environment artifacts and manage tools and host servers, your containers are managed. A PMP Planner is a tool that we first built for a large oil and gas service company in the Middle East, which I can't really go into detail on their names because of the confidentiality involved in building it. It was actually called a different name. And it was built as a project management tool to manage, obviously similar to your Microsoft project on Zoho, but the difference was that it actually had more productivity features such as expenses management, budget management. You could raise invoices in there, you do timesheets in there. It tracked everything that was going on. It used some level of intelligence to track whether a project was running late, whether the budget was not enough, was not going to be enough, and the timeline that was defined, and things like that. It's called PMP Planner. Please feel free to have a look if there's any interest in any of that. Xlite, obviously, we mentioned already, is a cybersecurity tool that focuses on protecting data, the data layer. So it ignores the firewalls, which we'll go into a bit more detail, and your identity management and things like that. What focuses on the data, and uses encryption, the highest levels of encryption, the AES-bit 256 AES-bit encryption layer to protect the data. Whatever it is, whatever location that data is, it protects the data and provides a controlled access with some proprietary IP things that we've built around it to make sure that once your data is secured by Xlite, it can't be hacked. And we ran a challenge last year because we sponsored one of the TechCrunch. TechCrunch is one of the biggest tech events globally in Silicon Valley. We ran an event last year in September. We ran an event last year in September, and we put a challenge of $30,000 to say, if you could break into some data that we've hidden, we'll give you $30,000. We got attacked, 150 attacks every week, but it was never up to date. Nobody was ever able to get to the data. It was published on Bloomberg as well. Okay, I've been privileged to be in conversations and vote formally, more informally rather, both here in Australia, the Minister of Cybersecurity. I've been involved in some of the conversations around drafting policy, some of the policy around hostile countries and exports from them, technology product exports from them. I've been involved in advising on how to get around that and what we need from a policy point of view. So quite a bit of work involved in advising politicians as well, various countries at different times on technology as well. I'm also privileged to have mentored the careers of about probably now over 17, probably closer to 20 now. Majority from Griffith. So I've been mentoring since 2014, both postgraduate and undergraduates. Obviously, we tend to mentor people we believe we can get the best results for, even down to, I think in QT, we've mentored people into jobs, into working for Accenture, into working for PwC, IBM as well. So my approach is we do whatever we can do to help you to understand where you're going and to have a direction of where you're going and how you can get there. And we give the best we can to do that. It's work that I really value very much as well. We currently have an intern from Griffith, and I'm not sure what he's here because I think 2 interns we currently have at the moment from Griffith University. I think one might be here. The other one, I'm not sure. I mentioned this to him. And another who started as an intern but is now employed as a member of our team, also from university as well. How I started my career. Now, I started my career, and I tell this story because I really want to, emphasize the fact that with a drive and motivation and learning and research and average intelligence, I'm going to use the word average intelligence, if there's any such thing, I think that people can get to where they want to get to. But it requires a lot of hard work and a lot of dedication and commitment and patience and tenacity and staying on course to where you want to get to. So that's the reason why I tell this story, to hopefully give you something to hold on to as well. So I started my career London Transport. Today is known as Transport for London, as a customer service assistant. I have a first degree in psychology, and I left university I studied psychology and I wasn't sure what I wanted to do. I have to be very honest. A lot of probably um, first degree, sometimes you don't have that guidance, and maybe it was just me, or maybe that's still something that's prevalent today. Understanding where you want to go with it. But anyway, first degree in psychology and then customer service assistant, feeling my way around, blah blah. Then one day I started playing. One day started playing with computers, and the rest was history. And I'll go into some details of that. I proposed an idea after logging onto a computer once or twice, and I proposed an idea, um, um, I, and I said, well, uh, on the stations and some of the centers where you would call, because you used to have this phone number you would call if you wanted directions on how to get on a train or blah blah. And I suggested an idea. I said, why can't we do something like that? What I didn't know was when I suggested an idea to my supervisor at the time, Benny's Jamaican, and I didn't realize that it was a project that was going on called Roots database system. They might still use it till date. And as of 15, 20 years ago, this was the main system that was used by Transport for London to disseminate information on where you're traveling to, or if you're getting lost, or if you want to know the train times and bus times and all that kind of stuff. Um, Based on me coming up with this idea, which I said to Benny. Benny is Jamaican, and if you know anything about Jamaicans, the language is very colorful. And I said to him, "Oh, Benny, we can do this. We can take all this information that is in a book, and we can put it into a database. And when someone calls and asks us directions, we simply just click a button." And Benny said, "Wow, you've got such fantabulous ideas. Go do something about it and come and show us and see if what you're saying actually makes any sense." And he said it in the most colorful manner, friendly, but you know what? Don't be flippant. Go do something about it. I did. I went back, I bought a computer and I learned and I started teaching myself. And I had a friend of mine who was already more knowledgeable than myself. He came, helped me set it up. And I spent the next weekends, to the dismay of my partner at the time, sleeping in front of the computer. And I wanted to learn everything. I bought some books. I learned the Microsoft Access, which was primarily the main tool I needed to use at the time. And I did that, and I took that, and I took the book that we had all this information on directions, and I put that information into an Access database, which today, when I think about it, was so rudimentary. I put it into an Access database, and I went back, put it on a floppy disk, and I'm sure a lot of people here would not know what a floppy disk is, if you're any less than 40, I think. But anyway, put it on a floppy disk. That's what we used. That was what we used instead of instead of um, a disk that you use now, digital disk now. And I took that, went back, and I went to Benny, my supervisor at the time. I said, "Oh, you remember you said something to me? Come on, see this." And I put it into a 486 machine, a 386 or 486 machine those days. I put it into there, and I showed him how you could click on A, and A will bring up a station. Click on A and give it direction. And he was fascinated, and he went and told his boss, who told his boss. Next thing I knew, I was seconded to report to the executive director of information strategy, who also reported to a minister. I sat in the office that the minister for transport, Stephen Norris at the time, sat probably 4 doors away from myself in 55 Broadway. Now, at this point, I started teaching myself Microsoft Access, obviously, and Windows 98, DOS scripts from books. I worked unpaid for 8 months as a trainee database administrator in a not-for-profit organization called Battle Bridge Centre, King's Cross, London, to hone my skills. Went back to university, studied for a master's degree, science degree in information technology. It was challenging, difficult, required a huge amount of learning on my own. Google was a few years away from inception at this point, so information was not readily available as it is today. My first job when I left university was a Visual Basic SQL Server developer, assigned to rewrite and enhance a newspaper distribution software application for News of the World. Spent 7 days a week working, learning, and teaching myself over 12 months. It was not a funny experience. It was hard, difficult, but I was determined. And I did everything, and I studied, and I used to stalk one of my friends' older brother who was already a software engineer. I literally used to time wherever he was. Every weekend I'll go find him, show me this, teach me this, show me this. How do I do this? This is blah blah blah. But anyway, that was my first job. In my house as well at the time, I set up an extra room as a data center, simulating computer networks, hosting database servers, all running on Unix servers at the time. Linux was beginning to show itself then. I think it was one of those first versions of Ubuntu at the time. I'm almost certain I lost a girlfriend or two at the time, as they would leave my house thinking to themselves, what a net, because you came into one of my rooms and it was all computers all over the place, connected. It was all nicely arranged with desk and everything, but I did simulate my learning as well. And that's where some of the knowledge came from. In 1998, my next job was supporting and enhancing an electricity billing system developed by Accenture for British Gas Centrica. British Gas Centrica is the largest supplier of gas and electricity in the UK. I think over 50 or 60 million customers at the time. And this is where my DevOps background started. At this point, it was not known as DevOps, but I fell into the category of application support or maintenance. DevOps as a concept existed and had practitioners prior to Patrick DeBoer, who's regarded as the father of DevOps, coining the term in 2009. Now, what is DevOps? So, continuous integration, continuous testing, continuous deployment, continuous monitoring. So, definitions. Software development approach emphasizing collaboration, automation, and continuous delivery to provide high quality products to customers quickly and efficiently. It breaks down silos between development and operations teams to enable seamless communication, faster time to market, improved customer satisfaction. It allows a team to handle the complete application lifecycle from development to testing, operations, and deployment. It shows cooperation between the development and operations groups to deploy code to production quickly in an automated and repeatable manner. Okay, I will explain that a little bit more in what we do and how we do it. We can build features of a product, roll it out, test it, and have it ready in less than a week. We've proven this, have it tested, and it will be bug free in less than a week. Now, I'm sure that one or two members of my team in this here who would attest to that, who have also come from Griffith University. The reason why we're able to do that is because of this concept. Obviously, with microservices as well, which lends itself to this concept, we are able to go from building to deployment ready for a customer to use with some of our features in 1-2 weeks. We run 2 weekly sprints, and I'm going to go into more detail. We run 2 weekly sprints. Those sprints produce products, and they're tested and working, and they're bug free. It's tested, it's security tested, and it's bug free before it gets to the client or to the end user. Every phase of software development lifecycle, including planning, coding, testing, deployment, and monitoring, is heavily automated in DevOps. This improves productivity, ensures consistency, and lowers error rates in the development process. A culture of continuous improvement is also prompted by DevOps, where feedback loops are incorporated into procedure to facilitate quicker iteration and better decision making. Organizations can increase their agility, lower costs, and speed up innovation by adopting DevOps. Now, it is one team or several teams working together in a seamless manner from building, I would argue, from requirements gathering, solution design, through to, because your solution design and requirements gathering starts with your sprints as well, through to developing a prototype, developing a product, developing something that is usable, all through to deploying it. So your build, your coding, your testing, your release, your deployment, your monitoring, your operations. It was not always like this. DevOps had to evolve or had to emerge because prior to this, which I'm going to go into, it was very complex. Building anything that you could say was suitable, would suit the requirements, and requirements had not changed, would suit the requirements as well as was fit for purpose as well. My DevOps career story. The electricity market in the UK opened up to competition in 1998. Centrica British Gas, which is one of the companies I spend most time doing consulting for, successfully applied and became a supplier. And Centrica had to develop over 30 electricity software applications to assist with bidding in the national grid. So you bid for power in the grid, just like you have here. Sales distribution, billing, support, and maintenance. 30 electricity systems now span over 300 development, test, pre-prod. So that's pre-production, so development, test, pre-production, the one before production, business as usual, BAU, support systems, training, non-functional load or performance testing environment, end-to-end and integration IT environments. These are all types of test environments or types of platforms where you develop, where you test, where you use to support the production system, where you give it to the user to test it, where you do end-to-end integration, where if several systems or several components need to talk to each other, this is where you test the integration, how they all talk to each other after you've tested them individually, which we call unit testing, which you can fit any of the test categories there. Now, these 300 IT environments needed code to be deployed to it every other day. And there was a tight regulatory schedule to deliver it. Testing carried out in them and monitored as well. In my team, on average, were individually responsible for deploying 2, supporting and maintaining 50 environments each. We had to write command line menu-driven Unix shell and Perl scripts to automate the process of pulling code for a repository called Perforce, deploying it to all environments to include production, then monitor and support the environment. These scripts and automation programs were makeshift DevOps tools or techniques. So let's look at it. If you look at things like Puppet, or you look at things like Octopus Deploy, or you look at IBM Urban Code Deploy, they're all deployment tools. We were writing these ourselves in those days. You wrote them in shell scripts and Perl scripts to be able to do exactly the same thing. That is where the need and some of the need for what's happened in the DevOps, how DevOps emerged, started. At this point, the need to build automation scripts to do these things, because obviously managing 300 environments, in some cases 1,000. I think the UK lottery was 1,000. We had to build. I presided over building over 1,000 environments. Bleed servers, IBM Bleed servers. I'm sure it was IBM Bleed servers. Over 1,000 of them at the time, and yes, very complex. So you had to automate some of these things. That automation is what evolved to become some of the DevOps tools you see today. Photograph of some DevOps tools and their function. I mean, several of them now. So many of them now. I mean, you got your collaborate now. So from your collaboration, which would mean, things like when an issue is raised, when there's a bug found in production, you go through Jira, you raise the issue. You've got Trello, you've got Asana, communication tools. You've got Slack, you got GitHub Export. There's several of them on the collaboration layer. So you collaborate to come up with a solution for a problem, to come up with a solution for an issue that has occurred in production, or for a new requirement. You start with those collaboration tools. You use this to build them. You build, and you build them. And you put them in repositories as well. And repositories are very important. And you deploy from repositories now. You deploy and you automate deploying from repositories, which is similar to what I just mentioned to you before, where we put it in Perforce, and then we wrote scripts, and then we push it out from there. And that's a similar thing to what you're finding here now with some of these tools. So you've got your Bamboo on there as well. Bitbucket, a Gitbucket, or a GitHub. We use the first layer and GitLab. These are areas that we use quite heavily ourselves. Obviously, testing, several test tools there. And there's LoadRunner, there's Selenium, JUnit. I think we use JUnit. JMeter, we use JMeter, PyTest as well. Obviously, in deploy, like I mentioned, you've got your Octopus deploy, your Rundeck in there, your Puppet, your Chef, your Ansible. There's several of them. You're all doing similar things, same thing. You got let's see that Python one there as well, and then execution as well. You're running, you're orchestrating, obviously things like Kubernetes help you orchestrate your Docker containers. In that you're running, you probably have things like OpenStack in there. Okay, the OpenStack is actually there. And that becomes this is exactly what the cycle now becomes as well, in the way that we deploy using DevOps methodology. And these are some of the tools that are out there that organizations are using to do that. Why DevOps emerged? Now, DevOps emerged to use both automation and better governance to bridge the gap between development and operations. Now, we've made that very clear that it did not work. In the past, what was happening was someone would develop code. So hang on, someone would design the solution or do the requirements, hand throw it over to that'll be your solution architect, throw it over to development team. Development team will build, throw it over to testing. Testing will test, testing will throw it over testing or and deployment team, for application maintenance, would deploy it and then maintain it. Now, in the past, these were made up of different teams and different groups. So nobody had the overall picture and overall experience of understanding the end-to-end cycle of that product from the solution architecture stage of the life cycle through to deploying it and operating it and managing and supporting it and understanding whatever problems it may have been, because sometimes these things get rolled out with bugs and with issues. But because the business, there's a lot of pressure from the business to roll it out, it gets rolled out. But what you're finding is that people who's at the end of that cycle, who are maintaining and supporting it, do not have a pretty good idea of some of the history or some of the issues this has had. So it became complex. Sometimes problems would occur, and to find out where these problems will come from, especially with very large integrated systems, when you have 150 systems talking to each other, exchanging data and data flows, when you have things like that, it became very complex to troubleshoot accurately and find out where the problem is to actually fix it. DevOps emerged to stop some of that. Now, is it perfect yet? Of course not, it isn't. Has it done something to make it a little better? I believe it has. Now the thinking is whoever is involved, at least from solution architecture point of view and development point of view, should stay across the whole cycle, even down to operations as well. So you can literally have a team, one team, or several teams embedded into one team running across your development operations, all through together, and recycling those skills across board to make sure that people understand how to fix issues when they come up. DevOps now catered or fostered quicker, more accurate releases to the production system. The blame game, because there was a lot of it. It wasn't funny, but it did happen. The blame game and the siloed practice which characterized the previous waterfall approach versus a now agile one, obviously DevOps is an agile one, of throwing code over the fence to another was eliminated mostly. The DevOps team now emerged as a now clearly labeled development and operations team to take ownership across the build, deploy to test, deploy to production, and support it in production. Companies like Google, Amazon, YouTube, Facebook adopting a microservices approach in delivering application features also pushed along the industry in this direction. And most organizations do. We adopt the same approach. All the things that we build today are built in that exact same manner. Now, this is obviously some of the methodologies that existed. The waterfall approach, which is actually what I started my career in, a lot of you would not see any of that. Well, will not see so much of that, even though some organizations might still use bits and pieces of that. But then you can see the cycle. You had to design, you had to build, you had to test, you had to deploy. Now, what that meant is that by the time you do all of this, maybe 1.5 to 2 years is gone. The requirement has moved. The requirement has moved. There is an example, and I use that example. One of the healthcare systems that was built for Queensland. I think the budget initially was, I think, somewhere around 100 million. That has now gone up to 800 million, and it's 3 or 4 years that they're still patching it. Now, I'm very clear with some of the work I've had to look at, some of the overview I had to do on that process. It's very clear that a lot of it was caused because of the fact that a strong waterfall approach was used, which meant that the requirements moved, changed, evolved. So if you're building a system and you cannot deliver that system in 6 months to 8 months, maybe 12 months, then you've got a problem, I think. You need to go back in my view, and do the requirements again and make sure that nothing has changed after 12 months. But that's what happened, and that's what was happening with this methodology. It created so much problems within the sector. And that's one of the reasons why you find a very large IT project. There is a reputation for very large IT projects to fail. There's so many of them. I mean, Queensland alone, I think there are 3 or 4 that's failed here. The government has gone to court with the IBM and Accenture, even in the federal level, Accenture and the defense as well. Large projects don't go very well. Sometimes, or some parts of it, at least in the past, had to do with this methodology, in the way this methodology was deployed, especially in the evolving requirements and changing environments as well. So obviously you now have the agile methodology. So the agile says, which is what DevOps mimics, which is what agile underpins the DevOps methodology. And you've got to design and you've got to build, you've got to test, you've got to deploy. Like I mentioned, we run 2-week sprints, and in those 2 weeks, a product is delivered or feature is delivered. For testing every single 2 weeks. We want two fortnightly sprints. So you design, you build, you test, you deploy. You design, you build, you test, you deploy. Continuously that way, and that underpins DevOps, as you can see: design, build, test, deploy. So the development and operations team are ready to cater for that cycle end to end, from design to deploy. Now, we'll go a little bit into detail on some of these tools: virtualization, containerization, Docker, and Kubernetes, obviously one known one. So you've got VMware there, your Docker, your Kubernetes. I won't go into too much detail here. Obviously, have questions come to me or ask me at the end. Creating virtually ring-fenced, logically divided computer systems hosted on a physical computer hardware device using software such as VMware Fusion, Parallel Desktop, Oracle VM VirtualBox, VMware Workstation, and Citrix for desktop virtualization. Now, Citrix is one I really don't recommend for anyone anymore, but that's my own personal gripe with that one. I don't think it's a tool. It eats too much bandwidth and requires too much resources as well. It had a significance years ago. Today, there's better technology to do some of those things now. Most infrastructure as a service, cloud provisioning services, infrastructure as a cloud, infrastructure as a service. Obviously, your AWS EC2, your Microsoft, your GCP platforms, provisioning services are underpinned by host server virtualization as well. So they literally buy a bare metal server and they virtualize it. That's really virtualize it. Some of those containerization is software deployment process that bundles an application code with all the files and libraries it needs to run on an infrastructure. We deploy Omnium Lite, which is one of the tools, as a container as well. It is very reliable, stable, makes it easy, and it makes it easy not to bother with trying to get prerequisite software onto a hardware server device, since it bundles and comes with all of it. We've used that quite successfully as well. Containerization negates the need for the deployed software application to depend on any other operating system libraries or version and execution time. Docker obviously is the most popular containerization platform, while Kubernetes is an orchestrating platform for things like Docker, obviously, and Containerd, which is another one as well. Cloud provisioning, Lambda serverless software stacks. So I talk about ATO as much as I can because some of it is wrapped around confidentiality as well. Obviously, Centrelink. Today, most of the digital services we consume from the Australian Public Service is hosted on AWS EC2 and Microsoft Azure and internal data centers. So what we call a hybrid cloud of some kind. Yep. Extensive use of OpenStack. Obviously, OpenStack is technology, and I believe it's owned by Red Hat, isn't it? It is Red Hat now, I think. Extensive use of OpenStack to provide infrastructure as a service cloud offering, converting bare metal servers into on-demand like IaaS cloud provisioning solutions. So if you log into AWS EC2, similar to log into AWS EC2, but OpenStack is used where you are gathering that this thing from. You have your own servers, your own mainframes, now similar, and you're using that to capture resources. And OpenStack helps you to orchestrate and capture that and serve those resources, for lack of a better way of putting it. OpenShift, again, working hand in hand, is now used to spin up from the OpenStack. OpenShift now used to spin up thousands of Docker-like containers hosted on infrastructure as a service infrastructure that serves to provide automatic computer system resources required by software apps, literally on demand and in seconds. I mean, this really works in seconds. The above arrangement also mimics Lambda serverless resource in the way that it's called up on demand. So Lambda is an AWS one as well, similar where you don't have, for like you don't start up a server, you start up several resources and it's pulled from different areas on demand and in real time, which gives you the resources that you need to run any workload that you need to. A software stack in use varies, but predominantly, this is for the ATO. is the main stack. MongoDB, Express, and Angular. MongoDB is becoming quite popular as people start to move a little bit more and more, particularly when you're dealing with volumes and volumes of data. People are starting to move a little bit more and more from relational databases. So MongoDB is not a relational database, if I remember well. Yeah, so that's the stack there. That's the stack over there. Obviously, AngularJS and Node.js, Express.js, and MongoDB, Java being the underlying framework there. Now, I mentioned OWASP, obviously, Open Worldwide Application Security Project, and I mentioned that as I'm sure in our midst, there are some software engineers here, or software engineers to be, people going more and more. Obviously, this is now a concept that the industry is pushing more and harder with the level of cybercrime that exists today. I mean, you can't pick up your phone, or anytime you see any transaction go to your bank these days, you hold your heart. You think, oh God, did I actually do that? You don't know if someone's got in. It's that bad now. It's bad with everything. Our data, any data you have, whether it's held by the government, is held by organizations, by the banks, insurance companies, whatever, is at risk. So we are going through very unprecedented times when it comes to cybercrime, and which is the reason why the industry is pushing so much more. As you can see, between 2017 and 2021, some of the things that have changed in there, a lot more emphasis as well, a lot more emphasis on building security across the software layer as well, which is not traditionally how it's been done in the past. I'm going to be more into that. Look at what I was done in the past, where your security layer, where the different, if you're referring to the OSI layer, your different, the front door layers, for lack of a better way. So your firewalls, as I mentioned, your identity management, and things like that, were the areas that and similar were the areas that were predominantly was used to secure systems and data. But that's today's date. The software application itself now needs to do its own work down to the data layer as well, which is what Exolite I mentioned to you. That's the underlying thinking behind developing Exolite as well. And so you can see that breaking access control, cryptography failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging, monitoring failures, server-side request forgery. Some of these certainly can be fixed from the can be assisted from the software layer as well. There's now renewed emphasis on security in the software application layer, especially as traditional methods like the network, firewall, and identity management layer are proving not to be enough anymore to impede cybercrime. Penetration testing should check and apply fixes for all the above to also include accurate encryption for data, both in transmission and rest, is now very paramount. In our team, we have several resources. We do penetration testing at all layers for all our products at all times. Before it is given to a client. So it's now built in as part of our process. When we do functional and performance testing, we also do security testing as a standard, as part of the agile cycle. Now, this is an example of what Exolite is doing, and just to further buttress the point about security at the data and the software layer as well. In this case, at the data layer, again, this is the concept here, where someone is breaking into an empty network and stealing data, attempting to break into a house and still go from a safe. Similar concept, burglars coming in. So you're using zero trust, two-factor or three-factor. Well, we use three-factor on Xlite anyway. Two-factor ID management and firewalls to protect against you getting into the system. In this case, breaking into a house, which is the image we're using there. Xlite with encryption and three-factor authentication provides the last line of defense for that data. So it says, even if you break through all of this, which they're now breaking through it, even if you've broken through the front gate, you've gone into the house, Xlite serves as the safe, if you like, to say, even if you did get to the data, you can't see the data. You can't make any use of it. It's encrypted. And we're also using three factors. I think fourth factor we're going to now. We've started developing a fourth factor now, which is biometric. I think that work is starting next week. We'll just bring it next week. So we're now building biometrics where you can use facial recognition for you to even see your data. but it's done in a manner that's seamless. So the same time it takes you to do two-factor, we use the same time to do four-factor. So if you use a minute to do your authentication, we're using that same minute, or with a few seconds additional to do it. So it's working literally in sequence, but it is four factors to show that you see your data. And that's kind of example OWASP is actually perpetuating as well. Now, I've added the slide as well. I'm sure that this is a new slide from last year. And I said, okay, let's for people who are looking to go into DevOps as a career, I must say that a lot of the work, and the reason why I went into some of my career path as well, is to tell you, I would argue that most of the work I did, I had to learn by myself. I taught myself, I forced myself to learn them. I did what needed to be done. There's no university degree that's going to teach you this stuff, and not at this level. If you want that knowledge, you need to find it. And we live in a time where there's knowledge everywhere. Some of the things I mentioned in the past, Google didn't exist as it is just today. There wasn't. It was all books. I still keep those books till date. They remind me of those days. A lot of books that you had to read and go through. It's not like today you have forums, you have places you can go to, you have guides, you have things. But this is the learning you need to do before you start going certifications as well. Learning about programming languages, JavaScript, Ruby, Python, Go. Learn about server administration as well. Learn about automation tools. Learn about CI/CD tools, which you mentioned before. Learn about network and security. Learn about infrastructure as code. Learn about servers. Learn about cloud computing. It's a broad area, but these are kind of areas for you to be able to do that job, for you to be successful in that area. This is the skill set. The skill set I have. This is a skill set I'm sure. This is a skill set, and I've also mentored a couple of DevOps engineers as well. And this is the background and the learning. One or two of them are certified now. This is the background and learning and pathway that they followed as well. Imagine information technology precepts. Now, the reason I've added this slide is I also want to say that this is a large sector, and today everyone's talking about artificial intelligence. But artificial intelligence is not the only thing. I mean, some of us have been working artificial intelligence for over 15 years. I mean, the noise has just started because of ChatGPT now, but some of them have been building tools in the last 15 years. Now, I must say that when I did my master's degree and I was taught about artificial intelligence, nobody knew it would advance the way it has advanced till date. I didn't think in my lifetime, or certainly in my professional career lifetime, that I would see artificial intelligence being leveraged in a manner it is today. So it's quite surprising as to the pathway and the speed at which it has evolved and progressed till date. But the point is, it is not the only area. There are several areas. There are different areas. If information technology underpins the way that we live, information technology underpins the way that we live in everything that we do. It is in everything that we do today. It means that it is a large sector. Some areas, noise might be made about them at different times. Today is artificial intelligence, but that does not in any way negate the fact that all these areas are areas that if you spend time perfecting your craft, learning it, staying focused and learning it, that you cannot become very successful in it. We need people, as an industry leader, we need people to partake of all these areas. We need enough skills in these areas. For example, in Australia, we lack expertise, we lack that skill set, we lack skill set across these areas in huge numbers. So it's not only all about artificial intelligence. There's metaverse, blockchain, quantum computing, digital immune system, hyper automation, datafication, industry cloud platform, wireless value realization, a digitally edible world, the hyper-connected intelligent world, sustainable tech. And we go into a bit more detail on the next one. Now, artificial intelligence, I'm not going to try defining that. We all have an idea, I'm sure, in this area, but obviously we're giving human-like intelligence using data, mathematical algorithms, machine learning, deep machine learning, and teaching a model to do some work, both predicting and automating, and to carry out a task that humans can do. We're using it to give intelligence to models that we write. And metaverse, obviously, you've heard about the metaverse, the Facebook one, even though I have my misgivings about it, but I won't go into too much detail about that. But yes, obviously us living through 3D models in a world underpinned by real-time interaction. Now, whether it will come to pass and how it will come to pass, I think my view is some elements of it would happen. I'm not convinced that the way this is being proposed, and certainly the way Facebook is going about it, that we'll end up in this world where we're using 3D models to interact. I can't see that world. I could be wrong. I cannot see that world. I can see some aspects of it playing itself out to solve various different problems, business problems, societal problems. I can see some of that, but I cannot see that in the manner in which Facebook is perpetuating it. But that's a personal view. Um, Blockchain, obviously, we know what blockchain is. Some of you probably involved in stock work there. But I think what interests me the most, blockchain, obviously, distributed cryptographically chained ledger that provides for visibility and all users collectively maintain control. That control means that blockchain can be employed to different areas that we need control, we need security, we need to make sure that things are authorized and done in a particular procedural manner. Quantum computing, obviously the big one, Deep Blue, Watson, a lot of work going on in there. Emerging technology harness the laws of quantum mechanics to solve problems too complex for classical computers. Yes, that is emerging, that is evolving pretty fast. I think that, and this is just a personal opinion, next 15, 20 years is going to be interesting in what we find from quantum computing. We may even well begin to leverage some of those in our personal computing tools and devices as well to do more complex work. I think that's certainly going to happen. Or it's already happening. Detailed immune system, protocols, technologies, and methodologies designed to protect networks, infrastructure, applications from various types of cyber threats. We're currently obviously doing R&D for Xlight AI, which is an AI tool, and I'm one of the interns here is actually working on this as well. We're using artificial intelligence to gather information on and predict, well, first of all, gather information on known perpetrators of cybercrime and how they do it, and their locations and their tools, methodology, and then using that to train a model that predicts, allocates and predicts using software robotics, predicts, allocates such perpetrators, their locations, and attacks back in an offensive manner, can be deployed to attack back. We're still going through more R&D on this, and there's actually some work capturing some of that data right now. We're looking for suitable partnerships as well to conclude that. That Xlight AI is I think it's a 3-year project that we've put in because of the amount of data we need to gather and the amount of work we need to do and the partnership we need to do with some industry consumers in deploying that one. But that's an example of that one there. Hyper-automation, continuous automation is stealing business processes with intelligence. Obviously, we're using robotics, we just mentioned but your physical robots and software robotics as well, artificial intelligence, machine learning, also underpins auto finding other processes to automate as well, and all to support human efforts as well. Datafication, again, obviously all the data, volumes of data captured by your Meta, TikTok, Snapchat, Facebook, collecting data and monetizing it in different ways, because by obviously they're collecting that data and then collecting money from advertisers, on the basis that advertisers' products and services can be shown to us, and they capture so much data. We saw what happened in the American elections, Trump's first election, where there was quite a bit of manipulation, quite a bit of information, quite a bit of sharing of data that shouldn't have happened. Some of the scandal that came up from that as well. Some of that as well. Industry cloud platforms, obviously platforms such as Amazon Web Services, your Azure, the GCP, obviously catering for storage, CPU, memory, on-demand manner for a fee. We use that quite a bit. I mean, we're quite heavy Amazon Web Services users and Azure as well as the GCP as well. Companies using cloud computing save 10% annually on infrastructure costs. Now that's been quoted, but there's a debate whether that's entirely true today. I think the opinion is beginning to move towards, do we really need the amount of expenditure? Because the more expensive some of these cloud platforms are getting, as decision makers are beginning to ask themselves, is it really even worth it moving into the cloud, or should I be maintaining my own data center or my own data center and running my own? Is it cheaper? There is a lot of conversations going on now in some forums I've been. Some foreign conversations where C-level decision makers are beginning to wonder if it is really saving 20% on annual infrastructure costs. But that conversation is ongoing at the moment. Wireless value realization, obviously, to describe the range of ways in which next generation wireless technology will soon deliver new and improved services and reduce capital costs. I mean, we can say it. I mean, there's 5G, 6G, powering Internet of Things in your homes now. Smart TVs, smart fridge, smart pool, smart every smart air conditioning, smart everything now. Mobile app, remote car start. Podcast that one. Obviously, with some of the artificial intelligence built in some of these modern cars, where cars are beginning to predict. You're too close to the next car. I'm going to stop the car for you because I don't think you know what you're doing. Now, rightly or wrongly, the level to which some of those things are working, um, I guess, is debatable, and how completely accurate they are. Whether artificial intelligence taking over driving my car for me is making better decisions than I would. If I had control of the car, I think it's debatable, and I've had a personal experience of this, but I won't go into so much detail on that one, which is the reason why I think it's debatable. But anyway, you've got that, and I think also the fact that you now have Starlink. Starlink, I think Elon Musk, in his quest to take over the world in every form and every way, Starlink is actually doing a pretty good job, because Starlink is affording the ability to have internet, uninterrupted internet access anywhere you are in the world. Based on satellite technology, which I think, as far as I'm aware, is probably the first one or has the best coverage so far, and is at the forefront. And that lends itself very quite clearly to this particular point here, the wireless value realization. So if we live in a world where something like Starlink covers the rest of the globe with wireless technology, automation, and some of these things we mentioned here, your powering IoT and telesurgery, and things like that becomes so much easier. So becoming hopefully a better world and automating things for us in a better manner as well. Um, digitally, digitally edible world refers to a concept where digital technology and information are seamlessly integrated into the way we produce, distribute, prepare, and consume food. Again, a lot of this is happening at the moment. Precision farming, smart packaging, blockchain traceability, some of that is doing. I know in the health sector, certainly with pharmaceuticals, I'm sure there are some countries in Africa that this is being deployed to, certainly in the Middle East as well, and probably to an extent in some of the Western countries as well. Hyper-connected intelligent world, again referring to Starlink as well. Obviously, your 5G, your CG comms connectivity, all underpinning a world increasingly getting digitally connected in the form of IoT devices, mobile maps, smart devices, interconnected robots, undertaking tasks, and automating areas for us in our life and making life easier for us as a society. Sustainable technology is the combination of two complementary ideas. The first is technology that is meant to remedy, improve, or offset carbonization, environmental setbacks or problems. The second is technology that's produced using green or ecologically responsible materials or processes. So those are all areas that require expertise, that require people going to these areas, that require graduates, postgraduates, learning the skill and perfecting these areas and taking it to the next level. And questions and related discussions. Questions pertaining to career paths in DevOps, cybersecurity, software engineering, business analysis, AI, etc., or across any emerging areas of industry are very welcome. Thanks, everyone.
Thank you, Valentine. Thanks for the insightful talk. I think it's very helpful and very insightful to see actually how this technology is used in Australia, especially the big organizations, how they what they're using and how they're using the things we're learning and things that can be applied. Questions, please.
Hello, Valentine. Thank you for your seminar here. I've got a quick question. Would you still recommend, a degree undergrad base and then work with that to a master's? Or would you recommend industry type certifications these days?
Sorry, can you repeat that again? Sorry, start again. I didn't hear the first part.
Yeah.
Mhm.
Would you still recommend going for an undergraduate degree to a postgrad or master's type degree to get a career in DevOps, or would you recommend like some sort of undergrad and then some industry certifications?
Okay, I'll go with the latter. I think that an industry undergrad is important. I think it gives the foundation. There are things that I learned. My master's degree was quite complex. Using that as a bit of an example, because even though it was a master's degree, it tried to capture 4 year, if a 3 year degree in I think it was 24 months if I remember well now. But then some of the concepts to date, and that was what over 20 years ago, some of the things that I learned from there, I still use till date in my understanding, especially when because I'm involved in doing a lot of the solution design of our systems and the ideas. A lot of it comes back to me. Some of the courses I did, it comes back to me in guiding me in the way that we come up with a new solution and design. So, short answer. Absolutely. I think an undergraduate degree is important. I think after an undergraduate degree, the jury is out because at this point now, um, you need the experience, you need that industry experience, you need that commercial understanding of how to apply it. So I think industry-based type certifications, opportunities for work experience, like I highlighted in my career as well. I did 8 months a voluntary piece of work, which was very helpful to me in learning and understanding Microsoft Access as a relational database. Um, so I think yes, that would be my thinking um, after a first degree. And certainly some of the people I've mentored already who've come from their first degrees and are fairly technical. I've encouraged them to go for more industry standard and getting more work experience, going out there and actually getting that knowledge.
Thank you, Valentine, for your
Yeah,
advice. Much appreciated.
okay, welcome.
There are questions in the chat. So Daniel has the question: are there any entry-level jobs you recommend looking at to get into DevOps?
Okay, so entry level on DevOps. That's I'm trying to think if I've come across not so much entry level because I think that the reason why you won't find I would rather say more um, entry level internships, uh, graduate type attachments were more on the area of software engineer, um, application support, um, those kind of areas you would get more entry type positions rather than DevOps. And the primary reason for that is because DevOps, the skill set in DevOps is quite varied. It's a very varied skill set. A very varied skill set because you know software, you know networks, you know software, you know networks. Some cases you know hardware, you know um, security, you know cloud computing, you know. So there are bits and pieces in it. So I don't recollect ever seeing an entry level I did some work with Wipro some years ago, and they have one of the largest workforces of in terms of numbers. I don't think I've ever come across an entry level. It would always be from one of those areas, either a software engineer or software engineer trainee, or type of training, or if you come from a networking background and now going into that and then learning through those areas. So I think no, I have never seen that. I don't believe. I've not come across that. But what I do know is that if you go in either through an internship or a graduate position, you can work your way around through that area as a career path into DevOps.
Thanks, Valentine. I think maybe from another angle, you can say there's a lot of entry levels, but they are not so-called DevOps
True,
positions.
true,
You can
true.
be called a developer, you can be called an
Correct,
administrator.
correct, correct,
Yeah. So from there, you work your path through.
correct. Very correct.
Um, Another question from Alexis. How do you feel about the recent CrowdStrike stuff? I think they did great. It's hard to hack a rock.
Okay, I have a very strong opinion about this one. Um, okay, so CrowdStrike. So we see ourselves as probably, obviously not in the same league, but similar to some of the things that we do. When we're building Xlite, we made a decision to build Xlite in a manner that it was not intrusive to the hardware device and the OS layer. It was a very conscious decision and a very big debate in my team as to there were some things we thought about doing which we viewed as, yes, we're supplying the product, but that could be seen as intrusive and almost hacking as well, almost hacking the operating system. So we didn't do it. So when you now hear that CrowdStrike and Microsoft, now Microsoft claims the European Commission insisted and allowed them to write code that was now talking to the OS layer. That's very, very concerning and very worrying. I think it should never have been allowed to happen. I think that the OS layer, the operating system layer, for the provider of that operating system should not be there should not be anything writing to it in the same manner that can manipulate it to the point where it can become vulnerable. So now, even though the argument was that the level of protection that CrowdStrike was providing as a tool required that, I beg to differ that it should not have been done that way. It left it vulnerable, and that's the result of what's happened.
Thanks. Okay. So I think it's very good to understand what the limitation of technology from that perspective. Sometimes
Absolutely.
if you got too far,
Correct.
you're creating
More
more
problems.
vulnerabilities. Yeah.
Yep. Yep.
Michelle, I'm not sure if I spelled the name correctly. What qualities or skills do you think distinguish someone as true great in this field compared to being just good? In your experience, what sets them apart?
Oh, that's a loaded question. I think that's a good one. Now, I have come across a lot of people in this field, some very good ones, some people who've done phenomenal amount of work. I think that there are two angles to this. I think that there are certain personalities that lend themselves. For example, Asperger's, which Elon Musk has, ADHD, especially in adulthood, and maybe there's a few other spectrums. I'm going to call them spectrums that either lend themselves to provide a personality that is very tenacious and very focused on getting a result, regardless of whatever challenge they see in front of them. I think in some cases there's a degree of personality that defines that. That's one aspect. Obviously, if that personality defines that, then it means that the person could become really great at what they're doing in the manner that they do it. On the other hand, I also think that there are people who are so determined, are so driven, are so motivated, and have been exposed to the right environment that they're so determined and tenacious and dogged in achieving the objective that they do whatever it takes, they learn, they overcome, and they do whatever it takes to become the best at what they do. They would read, research, understand, watch, and consume every amount of information they can find to guide them to achieving the result that they want. So in summary, 2 answers. I think there are personalities that lend themselves better, but I also think it can be acquired depending on how determined one is to achieve that result and to be the best at what they do, and how much they're willing to put into becoming the best at what they do.
Thanks, Valentine. Yeah, actually, some related thoughts, maybe consider as a following up question or comment. In the age of AI, people thinking some jobs could be potentially taken over by AI, and we really looking at those unique. I mean, attitude and motivation is something I think. Yes, I fully agree that distinguish a person in their career, in their study, in all sorts of things. So I think those factors, someone call this a resilience character kind of thing, that will
Absolutely.
make a people stand. Even, I mean, technology may change, but there's something unique to human that will shine even in those challenges. I don't know if you want to further comment on that.
So sorry. So yeah, the last part you said. Sorry, could you repeat the last part you said? Sorry, I didn't get yours, Mark. Yep.
Yeah, I think actually there's a question in my mind.
Mhm, mhm,
I mean, perhaps everyone thinking,
mhm,
uh, in the age of AI, that a
mhm,
lot of
mhm,
job roles will, they say, potentially taken over by
mhm,
machine.
mhm,
So what, maybe I don't know if it's too big a question.
mhm.
What roles do you think will be more easier to be taken over, and what people should prepare
Okay.
for?
You
Yeah.
know, I actually don't agree with that principle. I don't agree that AI is going to take over jobs. What I think here is I think that intelligence is going to create more opportunities. Because okay, I just at the beginning of the lecture before you start recording, I mentioned to you that we're now looking at mounting AI model on a drone. Yep, to do intelligent analysis of images that it finds. Even down to we're having conversations on seismic activity as well. Is it possible to use a drone and build intelligence to it to actually look at an area and start to speculate how much can be mined or drilled in that area? That's the kind of conversation we're beginning to have. We had a conversation with a company called Slumberger some months ago. Those are the kind of conversations that people are going to have. So the point I'm trying to make is that as artificial intelligence continues to advance, in my view, there are so many problems we need to solve in our society. There are things that are happening that we don't, that it's across every sector. Things that are either costing us a lot of money or things that have security implications to be doing the way we've been doing it. Things that can be automated to make things go faster, to make products come out faster, to produce things in the healthcare sector, for example, some of the illnesses we had, COVID, there are areas that artificial intelligence may be applied to quicken that process, to go for a process of launching a product, is something that can save lives from God knows 7, 8 years. When in Harvard they said it was 8 years to do some of that research, even though COVID changed all of that. Obviously, it didn't take 8 years to come up with this thing for COVID. But yes, that's so artificial intelligence and automation. So artificial automation, um, I see it as creating more opportunity. But yes, we may have to learn more skills, better skills, more on the business side. For example, we now need to go in and learn a little bit more about seismic activity. We're learning that because we need to understand seismic activity to the point that we establish whether we can write something, yep, and build a hardware with a software, with a firmware piece that can look at an area of land and speculate if that area is worth exploring for resources, products, for any kind of product at all. Now that's level of learning that without this technology advancing, we wouldn't have had to do that because there wouldn't be any point in trying to apply to it. There was nothing to apply there. So my argument is I've never been one who's confirmed this idea that AI, and I see this on, programs, and I just, AI is going to take jobs. No, I think it's going to create more opportunities, more areas that we need to apply it to. And that opens up a whole wide area of specialization, of occupations as well, is my view.
Thanks, Valentine. I'm very glad you said that. Yeah, actually, both Z and myself, we work in the area related to trustworthy AI and reliable AI, and there's a lot of things, a lot of hypes with the current AI. Even the big gents, IT gents, they kind of promoting
Of course, they are.
what AI can achieve, but there's very hard limitations. What
I know, absolutely. Yeah.
There was a question about, I think Janet has a question, how to get access to your mentorship program.
You got a mentorship. The nice ladies, I'm trying to remember the name now. The Canadian, what the name's now. You have a department for mentorship. I think you can search for it. So you go through them, then apply, then they will screen you, and then they would, if you can do a search and say you want me, and then they'll put me through to you. We'll screen your CV. I try to make, because we get, like 5, 6, 7 a year. I try to make sure that it's someone who we can actually give value to as well. And you have the right background. I've had times when someone's gone from, I don't know, real estate, and is now doing a master's in cybersecurity. And I really wouldn't know how to handle. There's not enough time to give you what you need in that kind of arrangement. There's not enough time. I mean, because you're literally coming from. I tend to mentor people, and I think it's worked better when they have my two. So I've got one. I think we've got one intern and one mentee now. The intern is pretty good. I think he's here. He's very good. It's already quite technical as well. And then the mentee as well is actually quite technical as well. But they're all. The intern is in his postgraduate, and then the mentee is I think is in the final year. But he's quite fair, has a strong foundational background, so it's easier to guide him. Obviously, we want to make sure that there's value, that we can give you something that by the time you leave. But we do it on a case-to-case basis, to be honest. So yes, if you go through the lovelies who manage that your mentorship program, and you tell them, also it comes through a portal and all that, and then we go through that process, and then that's how we do it.
Thanks. Avina said that's industry mentor program at Griffith.
Yes,
and,
correct.
Juniper said the name Nico Chambers. Not sure if that's the began to that contact person or.
Yes, I can put it there. I have their names somewhere. I chat to them almost every other week or so. So but the industry mentorship is actually, I must say, Griffith, because I'm also a mentor to QUT and the other one in the other one's name in Victoria. But the Griffith one is actually pretty good. I think it's one of the best ones I've seen. Obviously, I've been doing it since 2014, and I think there's some real results that have come out of some of the work we've done. Because obviously, some of the work we've done, we don't want to spend time mentioning someone if we don't think there's value added there. But I think there's been a lot of Bryce was one of I think Bryce was one of my first. Was Bryce in Griffith or QUT? I can't remember now. He did mechanical engineering, but he was playing around with building robotics, and that was one of the first mentees. Bryce, I think he runs is one of the founders of a company in London now. He's doing very, very well. Quite a few examples of a few people with that. Someone who went to work for Accenture as well, and a few others as well. Yeah, it's quite a few of them. I can't remember everyone, but it's the Griffith one is one of the best ones I've seen so far. I give the ladies the credit; they've done some pretty good work with that mentorship program.
Thanks, Valentine.
Mm.
I find some information on the
Okay.
web, so I put it into the chat for people who are
Yep.
interested to
Yep.
for internship opportunity and
Mhm.
being a mentee or in the mentorship program.
Mhm.
You can contact Griffith's contact. Let me see if there's any question remaining. I think there was a question related to blockchain. So how
Okay.
DevOps relates to blockchain or the other way around?
Not so much of a direct relationship. I mean, I'm not a, I'm not I like blockchain as a technology, but cryptocurrencies, I'm still cynical about the way some of it works for the moment. I would say this, I don't see any major, I can't see anywhere where blockchain has been deployed in the DevOps cycle that I've seen. I can't think of anything. But the fact they have a chained ledger type transaction, which I think is where in doing anything, but I don't see so much of I don't see so much of integration or underpinning DevOps at all. I don't think I can't think of any real. But blockchain on its own, it's technology that I think it's evolved and it's pretty good. Logically, it's a pretty good concept. Obviously, at the moment, it tends to underpin. I'm sure it's used for different areas. Obviously, biggest leverage of it is the cryptocurrency, which I have. I have my issues with cryptocurrency. It's but yeah, but I think blockchain itself is uh, a very decent structure to underpin any transactions, even escrow. And I don't know if escrow type transactions, which are transactions where you do where somebody needs to deliver something and somebody's put in escrow before that person delivers it. Blockchain technology can actually assist with some of that as well. I'm sure some of it is probably being used in that manner as well.
Thank you.
Mhm.
There's the final question. Well, more to come actually.
Okay.
What would you say the actual difference between DevOps and DevSecOps?
Security.
Yep.
Simple security. I mean, the different. In fact, I would argue that we need to stop saying DevOps and start saying DevSecOps because we are in a time now where that whole chain, that whole operation and development, or development and operation, has to be underpinned by security at every single angle of that chain. It's where we are today. So I would argue that DevSecOps is simply uh, DevOps evolving to deal with the current times.
It's giving more focus and more emphasis on security.
Correct.
By the way, a bit of a promotion. Just Valentine mentioned OWASP,
Mhm.
OWASP top 10 actually starting talking about them from next week. So
Oh, nice. That's pretty
stay
good.
tuned, and that we'll shifting more to the security side
Good.
on this topic.
Good.
Juniper has a question. Of the skills fields you mentioned, are there any skills you would recommend we focus on in order to break into the industry?
So when you say break it, are we talking DevOps now? Are we talking in general? I guess I need to clarify that.
I think in general.
In general.
Yep.
So okay, I would argue that okay, let me use we are a medium-sized company. A medium-sized company, most people will recruit, even on the sales area, even sales and marketing, have to have some degree of technical background. When I mean technical background, it could be technical awareness and understanding. But I mean, we have computer science background doing more product, what we call, because we have a role we call product specialist, which is a specialist, a product specialist who understands the product inside out and does the presentations and demonstrations to sell that product. Understands it inside out. Background is computer science, but on a day-to-day basis, they're doing more sales and marketing. So my answer to that is the easiest way to break in the industry is it is a technical discipline. Now, and I know that not everybody can afford, not everybody has or has the drive, the motivation to be technical or technical to a point. And there are various levels of being technical. My argument is if you do a computer science degree or information systems and technology degree, as a bare minimum, you need to be on business analysis skills, solution design skills, technical skills, software programming skills. So it is a discipline that requires you having a honed skill set. It's not like studying for history or English, or it is an area, it is an exact science area. It is an area that the best and the fastest way to make in the industry is having some degree of a skill set. Now, I watched one of my mentees who was trained from 15 to be able to do things like start up a cloud server, configure a cloud server from 15 years old. By the time he went into university, by his second year, PwC gave him an internship. A paid internship by second year. I'm sorry, by second year. By third year, they offered him a job. It literally took him out from university. And this happened in the last, 4 years? Now, the reason why PwC gave him a job very quickly was because of his background of what he had learned when he was 15, what he was learning, what he was doing from when he was 15. Now, not everybody has the exposure this person had to learn those things. But what I would say is the easiest way is teach yourself, train yourself skills in the area. In that whole area that I mentioned, there are areas of software engineering, software testing, business analysis, software design are the fastest areas in my view to get in because they give you definitive skills that the industry can consume immediately and then build on it as well. Is my response to that one.
Thank you. Any other questions? If not, thank you, Valentine, for
Thank you
for
very
the
much.
insightful talk and for all the helps, suggestions, comments. I think they're very valuable for our students. They love to hear from the industry experts. And what you said today, I think there's a lot of information. I think students will take them and digest. I think they would appreciate your talk very much.
Good.
Thank you.
Cheers. Thanks very much. Thanks, everyone. All right. Bye-bye.
Thank you.
Okay, bye-bye.